Okay, good afternoon. So we're quickly going to take a look at differentiation and integration of trigonometric functions. So by now you should be okay with basic differentiation, basic integration, but also some trigonometric functions. So if we start with exercise 16e or section 16e in the Cambridge textbook, they quickly give you a breakdown about the trigonometric functions and the derivatives of each. This is also in the formula booklet. If you go to the formula booklet under calculus, we all know the very basic derivative, nx to the power of n minus 1, and we have also seen the derivative of e to the power of x, and we've also seen the derivative of the natural log of x. Now in your formula booklet you will notice here the derivative of sine of x, cosine of x, and also tangent of x. So let's go back to our PPT. So we will see here that the derivative of sine of x is equal to cosine of x. The derivative of cosine of x is equal to negative sine of x. Do not forget about this, and when we integrate it's going to be the vice versa. The derivative of tangent of x is equal to secant square of x. So with this in mind, if we go to the exercises, so let's begin here and take a look at a couple of examples. So they tell us to differentiate the following. Let's take a look here at one. Let's first get the pen active. So let's take a look here at 1a part 1. So they tell us that y is equal to 3 sine of x. So if I want to find the derivative, I'm going to write dy dx is equal to, now please do not forget that the constant in front of sine of x stays the same. So I am going to write this constant here, whatever it is. In this case it is a 3. So the derivative of sine of x we know is cosine of x. So I'm going to write here cosine of x, and I can leave it as it is. So if I take a look here at B1, y is equal to 2x minus 5 cosine of x. If I find the derivative of this, dy dx, now I know that the derivative of x, so x is to the power of 1. So I say x to the power of 1, 1 multiplies to the front, 2 times 1 stays 2, x to the power of 1 minus 1, so x to the power of 0 is 1, so therefore it is going to be 1, so 2 times 1 stays 1. Minus 5 cosine of x, like I just told you, the constant stays the same, and the derivative of cosine of x is negative sine of x. So I can actually write it like this, negative sine of x. So 2, now this minus 5 times a negative becomes plus 5 sine of x. Now we haven't done anything with tangent yet, so let's scroll down, let's get a new page here, and let's take a look here at 1, let me write here, 1b part 2. In part 2 here they say y is equal to tan x plus 5. So let me just write it. If I want to find the derivative, dy dx, of tangent of x, so tan x, we see here the derivative of tan x is secant squared x. So I'm going to write here secant squared of x plus 5. Now the derivative of a constant, of a number, remember there's no x. So this is x to the power of 0 if I wanted to think about it like this. But the derivative of a constant is 0, so I can just here plus 0, or I can just omit that. Okay. I do not have to write this plus 0 at all. Let's activate the pen, sorry for that. So I do not have to write this at all. Let's take a look at one more example. So 1c part 1. They tell us the following, y is equal to, so I see sine x plus 2 cosine x over 5. It is one big fraction, but I do not like this one big fraction, so I want to separate it. So I'm going to write here a fifth sine of x plus 2 over 5 cosine of x. And now it is easy to differentiate dy dx. I know that sine of x, the derivative of sine of x is cosine of x, so it's going to be 1 over 5 cosine of x plus 2 over 5, and now the derivative of cosine of x is negative sine of x, and I can simplify this as 1 over 5 cosine of x, now plus a negative, so it's going to become minus 2 over 5 sine of x. So when you want to differentiate, it's actually very simple. These are only the simple or the basic trigonometric functions, sine, cosine, and tangent. If you look at your formula booklet, you will see here that in the next chapter we're going to do the derivative of secant, cosecant, and cotangent. So there are some more difficult derivatives of trigonometric functions. Then let's go back to the PPT. Okay, so we've taken a look at that. Ooh, there's one more. Let's try finding the gradient of a function at a specific point. So let's take a look here. They tell us find the gradient of f of x is equal to sine x plus x squared at the point where x is equal to pi over 2. So if I want to find the derivative of this function, so I say here f prime, the derivative of f. The derivative of sine of x is of course cosine of x. The derivative of x to the power of 2 becomes 2x. Now when they tell me to find the gradient at a point, I have to plug this point into the derivative. So this will be pi over 2. Now I'm going to write here cosine pi over 2 plus 2 times pi over 2. Of course, from our previous knowledge, we know that cosine of pi over 2. Now, if you struggle with radians, you can always convert it to degrees. Pi over 2 is the same as 90 degrees, and I know that cosine of 90 is equal to 0. So cosine pi over 2 is equal to 0. And I can, oops, not a plus, equal to plus 2 pi over 2, so the 2's cancel out, plus pi. So this is just going to be pi. So this is my only answer that I get here. And it is very important that you are able to simplify trigonometric functions. So this is the basics of the derivatives of trigonometric functions, sine, cosine, and tangent. Let's take a look at integrating these. So when we want to integrate trigonometric functions, they give us the integrals here. So the integral of sine of x is equal to negative cosine of x. Now please do not get confused. If I go back here, the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. So it is only natural that it should change. The integral of sine of x becomes negative cosine of x, and the integral of cosine of x is positive sine of x. And this is also in your formula booklet. Now, if I want to find the integral of tangent of x, it is equal to the natural log of secant of x. Now, if I go to the formula booklet, so these are all the derivatives, I scroll down and I find standard integrals. I will see here the integral of sine of x is negative cosine of x, the integral of cosine of x is sine of x. But we do not see anything about the integral of tangent of x. So make a mental note that you will have to go and remember this integral as it is not on the formula booklet. So let's go and apply this knowledge to some problems. Exercise 17E. Let's take a look here. So I'm going to start with 1A, part 1. Let's start simple. So they're telling us the integral of sine of x minus cosine of x dx. Now we can see here that the integral of sine of x is negative cosine of x. So I'm going to write negative cosine of x minus cosine of x. So the integral of cosine of x becomes sine of x. Do not get confused and think that it is a negative. Now please remember when you write the integral to write dx. So we are integrating in terms of x. But when I am done, these are indefinite integrals, so I have to write plus c, plus a constant. So please do not forget about that. Let's take a look here at B, part 1. The integral of 1 plus tangent of x dx. So the integral of 1, we all know, is equal to x. And tangent of x, the integral of tangent of x becomes natural log, absolute value, secant of x, absolute value, plus c, the constant. Let's take a look at something a little bit more interesting. Let's go and try C part 2. So for C part 2, they ask us for the integral. Now again, I see that this is a fraction. So I want to separate this fraction to make it easier. 1 over 6. And if I see square root of x, I can immediately write x to the power of a half plus cosine of x dx. So the integral of 1 over x to the power of a half. So what do? I'm going to say a half plus 1. This becomes 3 over 2. So let's write it all out. So 1 over 6 multiplied with the reciprocal of 3 over 2, and this will become 2 over 3, and x to the power of 3 over 2. This is how I integrate the first part. Plus the integral of cosine of x is sine of x plus c. Then all we have to do is we have to go and simplify this. This becomes 2 over 18, which we can later simplify again. 3 over 2 plus sine of x plus c. And this we can simplify as 1 over 9, x to the power of 3 over 2 plus sine of x plus c. Okay, so let's take a look at the last example here. Activate the pen. Okay, so let's go and take a look at D part 1. They tell us to find the integral of 1 minus, and now the first thing I want to do is I want to expand these brackets with a negative. So I'm just going to say negative cosine of x minus sine of x dx. So if I want to integrate 1, so the integral of 1 I know is x because we are integrating in terms of x. The integral of cosine of x is positive sine of x. So I'm just going to write here minus sine of x. The integral of sine of x is negative cosine of x. So if we think about it, so I bring down the negative, and the integral of sine of x is negative cosine of x plus c. And I can simplify this x minus sine of x plus cosine of x plus c.